Good morning. It's a pleasure to stay here today. I am Encarnación Coca. I am going to present some preliminary some results of the last research. Currently, it's very difficult to find all living trees because they only exist in inaccessible places. And pollarding is a traditional practice to obtain bulbs that promote their conservation. This practice was very important, but over the years it decreased. Pollarding was many species, Quercus, Fagus, Vaccinius, etc., although in the West Siberian the most common were the Perian and deciduous oaks formed dehesas. In the Temperian environments, 3-4 visible growth rings in their xylems. These rings are formed mainly by the seed cells and can be assigned calendar years. Therefore, all the event experiments by the trees are permanently recorded. The reed porous species, as deciduous oaks, have two distinct two types xylems. Early wood is characterized by wide bases to facilitate water transport, and late wood composed of the matrix with dense fibers to the support of the tree. Pollarding consists of cutting tree branches but preserving the stem. Therefore, after the pruning, there is a reduction in the stem growth due to trees invest carbohydrates in recovering what was removed. For example, in this picture, you can see the early wood made in pink color and late wood in green color. The objectives are the detection of the pruning using an automatic supervised of the algorithm and the reconstruction of the path of the management. Firstly, we chose 4 pollard oaks woodlands in Soria, central Spain, and samples Quercus pyrenaica and Faginia, resulting a total of 200 cores thanks with press boiler. Then samples are mounted in a bulb support, samples and digital using a capturing. We use different softwares to cross data, measure digital images. We train the random forest algorithm with the sub-8 trees. We added different variables to the algorithm random forest, such as the ring width, early and late woods, and some more derivatives of them. The variable most significant was the late wood, thanks to Gini index, which considered in a 1 and 2 years time windows. In this example, we can see how there is a very evident reduction of the late wood and a slow progressive recovery in the following years. We violate the algorithm using 2 metrics, and area under the curve is a measure of the model ability to distinguish between positive and negative case, and the result in the 0.98, which is a good value. Accuracy measure in the proportion of the correct prediction in the ratio to the total, to obtain a 0.77, which are also a good value. With these results, we can affirm that the algorithm detects pruning satisfactorily. Okay, to the reconstruction historical management, we analyze firstly the pruning frequency as the number of the pruning per tree and century. We then comparative the frequency between century using a pairwise comparative model. The frequency is considerably reduced over the century. For example, trees are pruned 11 times, average in 16th century, and now only 4 times. We can see that all centuries show significant difference with the 21st century. Another measure, the historical management, is the intensity of the pruning, which is the number of the years between the pruning event and the first signs of late bud recovering. This example, we can see the late bud of Bilvestre tree. The red dots show the pruning events, and the last line show the recovery time. Depending on the intensity of the pruning, the recuperation period can be higher or lower. Being the more intensity the pruning, the longer the recovering. The intensity of the pruning also varied across the centuries. In 17th and 18th century, the intensity was on average 3 years, while the other century was 2 years. The most of centuries saw significant difference with the 20th and 21st century, except the 16th century. Here, you can see the recurrence and intensity of the old trees and sites. Understanding recurrence is as the time lapse between 2 prunes. Recurrence is represented with a soft line and the intensity with a dotted one. Thus, we see that the intensity and recurrence are negatively related. To sum up, we can detect its pruning thanks random forest, and thus reconstruction of the frequency and the intensity of pruning over time. Our results show clear difference in the management from 16th century to the present. Thanks for your attention.